Hello students, today I am going to cover up the second algorithm of CPU scheduling, that is your SJF, shortage of first. It is a special algorithm in which the shortest job gets the priority. The SJF algorithm can be further divided as SJF and SRTF. If a algorithm is non-preemptive, means once the processor is assigned to that process, will continue until will not it get complete. So that is known as the SJF. While in case of primitive SJF is known as the shortest remaining time first. So we will discuss in the next few slides. Since it is a special case SRTF of the SJF, that's why I am covering these two algorithms simultaneously. So it is an algorithm associated with each process length of the process next CPU burst, means how much time it requires next to get execute. When the CPU available, it is assigned to the process that has the smallest next CPU burst time, means whatever the time remaining is the maximum, it is assigned the CPU assigned to that process. If the next CPU burst of the two processes are same, this is the important one. If there is a tie, so in that case, FCFS scheduling algorithm is used to break up the time. For example, there are three processes P1, P2 and P3, and their arrival time is 0, 1 and 2. And burst time of process P1 is the 1 and it requires 2 and 2. So for 1 second, firstly, at the time 0, there is only one process, that is P1. So P1 will get execute, and after completion, it will remains the time 0. And now process, suppose that both process comes at the time 1 second, and also the burst time is 2 seconds. Now the remaining time is both processes have is 2 millisecond or 2 unit of second, now which will get execute. So here we will consider the lowest number of the process, that means the 2 is the lowest, so we will assign the processor to P2 process rather than the P3. So we are considering here P2 is come first and then after P3 comes. So tie can be break up using the FCFS. SJF algorithm can be either primitive or non-primitive. So non-primitive means once the processor is assigned to a particular process, it will continue its execution until the time slot or the burst time will not get completed. While in case of primitive, the processor is snatched voluntary if a lesser burst time process appears in the ready queue. So there are two algorithms, preemptive and non-preemptive. The non-preemptive is named as SJF, while preemptive is named as shortest remaining time first. So we will cover up these two algorithms with example in the next slides. The choice arrives when a new process. The choice arises when new process arrives in the ready queue while the previous process is still executing. The next CPU burst time of newly arrived process may be shorter than what is left of the currently executing process. A preemptive SJF algorithm will preempt the processor from the currently executing process and hand it over to the newly arrived process that has the lesser amount of burst time. The preemptive SJF scheduling, sometimes also known as the shortest remaining time first. Advantage as SRTF is optimal and guarantee the minimum average waiting time. It provides a standard for other algorithms since no other algorithm performance is better than it. So it is the best algorithm. Disadvantages cannot be implemented practically since burst time of each process cannot be known in advance. When a process arrives, then we can understand what is the burst time. It leads to the starvation for the process with the longer time. Means the process, this may be possible, the a newly shorter time process are arriving continuously, and the process that have the larger amount of burst time may not get processor anytime. So in that case, there will be the starvation condition. Priority cannot be set for the processes. Process with larger burst time has the poor response time because it has to wait for a longer amount of time until it will not get complete. So it will not allocated the processor. How will it get the response? So definitely the poor response time is there. Now we are considering an example SJF with non-primitive. We have to calculate the average waiting time and average turnaround time for this process. Since this processor is it is a non-primitive, so processor cannot be snatched from the currently executing process. So let us explore the example. There are five processes P1, P2, P3, P4 and P5. The arrival time is given as follows and the burst time is also given as follows. Now calculate firstly to calculate the turnaround time and waiting time, we must find out or draw the Gantt chart. So Gantt chart is as follows. At the time 0, there is only one process that is your P4. So it will allocate the processor. Since it is a non-primitive, that means the processor cannot be snatched once it is allocated to a particular process. So P4 will get the processor at the time 0 and it will continue its execution for the 6 unit of time. So it is continued for the 6 unit time. Then after in the meanwhile in the 6 unit of time all process has been arrived in the ready queue because this arrives at the 3 unit of time, this arrives at a 1 unit time, this arrives at 4 unit of time and this arrives at 2 unit of time. Now all the process are in the ready queue. Now I will search for the shortest amount of burst time. Here I find P1 has the least or the shortest burst time. So P1 will be allocated to the processor. It will execute for 1 unit of time as its burst time is the 1 unit of time. Then after P3 will get executed for 2 unit of time and then after P5 will get execute for the 3 unit of time and at the last P2 will get execute. So this is the way how to prepare the Gantt chart. Now I am calculating the average turnaround time and average waiting time. As we know that the formula average turnaround time is equal to completion time or exit time minus arrival time. So here for the process P1, for the process P1, the completion time is the 7 and its arrival time is the 3. So this will be is equal to 4. It is depicted here. Similarly, for process P2, its completion time is the 16 and its arrival time is the 1. So 16 minus 1 is equal to 15. For process P3, its completion time is the 9 and its arrival time is the 4. 9 minus 4 is equal to 5. For the process P4, its completion time is the 6 and its arrival time is the 0. So 6 minus 0 is equal to 6. And for the process P5, its completion time is the 12 and its arrival time is the 2. So it will be 10. So we can calculate the turnaround time by this method. Now, waiting time. As we know that waiting time for a process is equal to turnaround time minus first time. So turnaround time for the process P1 is the 4 and the burst time is the 1. So 4 minus 1, it is equal to 3. Similarly for the process P2, 15 minus burst time 4, that is 11. For the process P3, turnaround time is the 5 minus its burst time is the 2. For the process P4, 6 minus 6 and so on. So that by this way we can calculate the average burst, we can calculate the burst time for each process. Now, how can we calculate the average turnaround time and average waiting time? We will say for calculating average turnaround time, we will add the turnaround time of each individual process divided by the number of processes. So it is 5 or 4 plus 15 plus 5 plus 6 plus 10 divided by the number of process, that is 5. So it will be 8 unit. Similarly, average waiting time, sum of all waiting time divided by number of process 5. So 3 plus 11 plus 3 plus 0 plus 7 divided by 5. So it will be 4.8 unit of time. So this is all about the non-preemptive SJF, that is basically known as the SJF. Now coming on the primitive SJF. Primitive SJF, that is known as the shortest remaining time first example. So here again 5 processes are there and SJF is now primitive and arrival time is given, bus time is also given. So firstly, let us draw the Gantt chart. How will we draw the Gantt chart? So here are the 5 processes P1, P2, P3, P4 and P5. At the time 0, there is only one process, that is the P4. So it will be allocated the processor P4. I can show you by drawing, that will be better one. So firstly, at the time 0, the processor P is allocated to process P4. Now, after 1 second, a new process arrives in the ready queue. So, after completion of the 1 second, the remaining burst time will be 5. Now, there are two processes in the ready queue, P2 and P4. Now, the burst time of the process P2 is lesser than the P4. So, automatically, the processor will be switched over to the process P2 because it has the lesser amount of bus time and we are using the preemptive, means छीन लिया जाएगा, snatching is there. So the processor will be snatched from the process P2 P4 and allocated to the P4. So now processor, this will execute for a second and now process P2 will execute by the processor. Now P2 requires the bus time of the 4 millisecond or the 4 unit of second. Now after executing of the 1 second, a new process arrives at the 2. So the remaining time will be 3 of this after execution of the 1 quantum of time. Now at the time 2, there are 3 processes in the ready queue, P5, P4 and P2. The shortest remaining time of which process, let us consider, let us check. So 3 5 and again 3. So there are two processes that have the equal time remaining or the bus time. Now here is a tie. So in case of tie, I have already discussed the process that come first will get the priority. So here the P2 comes first, so it will continue its execution. At the 3 second, a new process arrives. So after completion of 2 seconds, a new process it will check for the now remaining time of all processes in the ready queue. So here it is 2, it is 1, it is 5, and it is 3. So shortest is of P1. So the processor will be snatched after 2 milliseconds from the process P2 and handed over to the process P1. P1 will execute for a second. Now its burst time will be 0. At the 4 second now next process arrives at the time 4 unit of second. Now it requires the 2 millisecond. All processes are in the ready queue now. P1 has finished. Now processes are P2, P3, P4 and P5 in the ready queue. The P2 and P3 has equal time of interval required. So there is a tie. When there is a tie, we will follow the FCFS. The P2 comes first, arrived first. So P2 will get execute for 2 seconds and now it will become 0. Then after, now all processes are in the ready queue. So the next shortest process is the P3. So P3 will get execute for 2 millisecond or 2 unit of time. Now it will be 0. Now it is 3. So P5 will get execute for 3. That means 11. And now it is also 0. Now the only remaining process is the P4 in the ready queue. So P4 will execute for the 5 unit of time. So it will be 16. So this is the way how we can calculate the Gantt chart or draw the Gantt chart for each process. Now, once we have calculated the or draw the Gantt chart, now we have to calculate the turnaround time and waiting time for each process. So as usual in the previous slide or in the previous numerical we have done. So turnaround time for the process P1 will be completion time. Completion time P1 for process P1 it is 4 minus arrival time 3. For process P2 it is 6 minus arrival time 1. For process P3 execute complete its execution at the 8 minus arrival time 4. Then after for the process P4 16 minus 0 16 and P5 11 minus 2, that is 9. So this is the turnaround time. Now waiting time is the turnaround time minus bus time. So turnaround time for the process P1 is the 1 and its bus time is 1, so it is 0. For process P2 turnaround time is the 5 minus bus time is the 4, so it is 1. For the process P3 turnaround time is the 4 minus bus time is the 2. Then after for the process P4, the turn around time is the 16 minus bus time is the 6. So it will be 10. And for last process that is your P5, turnaround time is the 9 minus bus time is the 3. So it will be 6. So by this way, we can calculate the turnaround time and waiting time for each individual process. Now we have to calculate the average turnaround time and average waiting time. So average turnaround time will be sum of all turnaround of the processes divided by the number of processes, that is 5. So here will be 1 plus 5 plus 4 plus 16 plus 9 by 5. Similarly, the average waiting time 0 plus 1 plus 2 plus 10 plus 6 by 5. It will be 3.8 units of time. So this is the way how to calculate the turnaround time, average turnaround time and average waiting time for each process, no, for the processes present in the ready queue. Firstly, we have to calculate the turnaround time and waiting time for every process. Then after we have to find out the average. So this is from my side. Thank you.